We're going to talk about some of the scariest words in physics. One is quantum. You know that's a scary word. Relativistic is a scary word. But the word that makes those scarier is field. Quantum field theory, relativistic fields. The word field, for some reason, sounds intimidating in physics. So what we're going to do first is just convince ourselves that at least mathematically, a field is not so bad. So let's look at a field and work our way towards a nice definition. So think back to when you took algebra. Maybe it was 5 years ago, maybe it was 50 years ago. And the first thing you talked about in algebra was a function. Function was simply you have an x-axis here, a bunch of values of x, and for each one you assign it f of x. The simple idea of a function. Maybe it's a table of numbers, maybe it's a mathematical formula that gives you the f of x for each x, and you can plot it, and it looks something like that. So functions, I'm going to assume you're very happy with. What if we had a function of 2 dimensions? Here's y, here's x, but we could still plot f here, and it would be f of x and y. For each x and y, there could be a unique f. And it would make, if I plotted it, its height is f, just like I did here, but in 2 dimensions, it might look kind of like that. It might have a nice little shape like that, where each point here has a corresponding x and y. So what is that? That's a function in 2 dimensions, but I would call that a field. So really a field is just a function in higher dimensions. You could think of it as we have a field of values here. We have a field of x, y values, and each one of them has an f. So really mathematically, field doesn't really mean anything beyond function. Just generally as we talk, we call things in 1D functions. We might call things in 2D fields. Although in physics, actually, we call everything everything. It doesn't really matter. And you might say, well, what about 3D? Could you have a 3D field? And the answer is yes, of course you can. X, y, and z, and now it becomes hard to draw. Okay? So here, if I were going to draw this field by saying the size of the circle represents the size of f, I could have a big circle right here and have the circles get smaller as I go farther away there. And I could try to give you some idea of a 3-dimensional thing in space, like that. Okay? You can imagine this function, or this field in 3 dimensions gets really big right here and it's small everywhere else. That's one way I could attempt to draw f of x, y, and z. All right? So if we wanted to go with one of our simple little definitions, let me write it down here, this is a field. The definition would just be, for the purposes of this class, a field is just a function of 2 or 3 dimensions. That's all it is. Okay. Oh, so I see we have a question. Let's see. Belieber 2237 asks, the fields are scalars. The fields I showed you, these fields are scalars. Can fields also be vectors? So the answer is yes. So the things I drew here were scalar fields. I just draw height as a function of 1D. I drew a surface in 2D. That's again just a height. And when I drew the 3D field, I drew circles with a certain size. Those are all scalar numbers. But yes, you can have a vector field. You can have each point in space a vector pointing different directions. So you can have a position in space and the vector pointing in a different direction. And that's where fields start to get hard, when you have vector fields and you try to do calculus with them. But just to get started, keep in mind that a field really is just the old function that you're used to.